Shiver me timbers. Don't ask me how they brought us on like that, but we're here, and it's nice to be here because 10 seconds ago we were down smoking cigarettes in the boys' room downstairs. And here we are, and it's nice to be on television. And yeah, I left a little math question hanging at the end of the last show concerning the diameter of the moon. But before we get around to that, Neil pointed out an interesting piece of journalism in the Winnipeg Sun a couple of weeks back. And this is a funny thing. Sun staff writer Greg Pindera has researched a question of Manitoba's Institute for Sustainable Development.
I think it's International Institute of Sustainable. There's two I's in there.
The International Institute of Sustained Development. Known around the world? Not. Okay. Now, this is the kind of thing, you know, the politicians say when they're pumping millions and millions of dollars. What this means for the city of Winnipeg is phenomenal. It puts the city in the international forefront of sustainable development. It could do more for the city than the Winnipeg Jets. Okay. Sounds, you know, we're really going to be at the forefront, and they got all these politicians saying what a great thing it is. But it turns out now, these guys have researched the question. I don't know how they did this, but apparently, if you get like a telephone directory for cities like Geneva or London, Washington, there's like a section in the yellow pages, you know, Sustainable Development Institutes of. Now, they've all got different names. For example, there's one in Washington called the Global Legislators for a Balanced Environment, and there's one in London called the Panos Institute of Sustainable Development, and they're all over the world. All the major cities have these things. So they phoned up the directors of these renowned institutes and asked them if they've ever heard of the International Institute of Sustainable Development, which is the one here, you see. And for the most part, well, the unanimous, overwhelming response was no one had quite ever recollected distinctly, haven't heard of it.
The only person they found that had heard of it was someone in Nepal, who
was a former Winnipegger
who went there 2 years ago.
Yeah, that's right. Yeah, she'd sort of heard it. She said, "Is it in Winnipeg?" Yeah, she said, "Yeah, that's the one. I know about that. I've heard of it. That's where I come from." And this is the kind of journalism. And did I say Greg Pindera was the writer of the article? I don't know what his role was in conceiving this story, but I consider it an excellent piece of journalism. And incidentally, Greg used to be with the Free Press, and at that time he was the writer that did the very first feature on Math with Marty ever to appear in print. They had a little story on us, and it was only 6 weeks into our very first season on the air or thereabouts. The show had attracted a kind of a cult status even then. I never quite understood why, and I'm still thinking of ways that I can personally cash in financially on our cult status. I'm working on it. But now he's apparently with the Sun, and we certainly enjoyed reading that fine piece of journalism. And is there anything I forgot to say?
That's about it.
Yeah,
that was the article that devoted a good portion of it to Sharon's feet, Sharon playing with her feet.
Yeah, that we didn't find all that
funny things. Greg, yeah, we had mixed feelings about that. We enjoyed it, but none of us remembered Sharon playing with her feet.
No, she did come barefoot to this. It's true, she did come barefoot, and I did make her change her socks when we come down tonight. She was wearing, she was wearing something outrageous. Well, she's in architecture, as I've told the people, and she's virtually graduated. Okay, she'll be an architect. As far as I'm concerned, she's an architect already, but you know, she's still kind of university-ish, and architecture is heavy on the artsy end of things. So sometimes, you know, she doesn't quite measure up to the dress code for the program.
Sorry about that, Mom.
There you go. That's more like it, Sharon. No, she did come bare feet way back once or twice, okay. But it was summertime in Winnipeg. What are you going to do? Okay. Yeah, I wanted to finish this thing off. I said last time that if you hold up your pinky nail to the moon, that the moon is about half the diameter of your pinky nail. And I was just sort of guessing on this thing, but I went outside. It's like 11 o'clock at night right now, and the moon is low in the sky, and it's real hazy, and it turns out it's just sort of a blob through the haze. But I held up this ruler, and as near as I could tell, it's like between 5 or 6 millimeters, okay? 5 or 6 millimeters, the diameter of the moon, and that's not all that accurate. And then what we did, we measured the length of my arm from eyeball to where the ruler is sticking out, and it turns out to be 57 centimeters, millimeters? What would it be? Yeah, 57
it has to be centimeters.
You know.
Has to be centimeters.
Have to be 57 centimeters. Yeah, that's right.
Half a meter.
Yeah. Okay, yeah. 57 centimeters, and that means like if it was 5 or 6 millimeters for the diameter of the moon, we're talking is 1%. And what I'm trying to say is, what can you make of this 1%? And certain things you can get out of this quite directly, but for certain other things you need to bring in a factor of pi. And this is what I want to show you, why you need a factor of pi in here. Okay, certain calculations you can do. For example, if you know that it's 250,000 miles from the Earth to the moon, okay, then you can conclude from this 1% ratio that the moon has a diameter of 2,500 miles, which is about right. Conversely, if you know that the moon has a diameter of 2,500 miles, you can estimate that it's then 250,000 miles from the Earth to the moon. Okay, it's again the 100-to-1 ratio appears directly in those calculations. I think you can see how that works. And incidentally, if you're not given either of those facts, which of course was the astronomical problem, that you didn't know either of those facts and you had to get both of them. Okay, so one was as good as the other. If you could get one, you had them both. But the problem was getting one of those facts. And I have a strong feeling that even in the Greek times, they had some idea of at least some of those. John, are you aware?
Shadows during an eclipse?
Ooh, shadows during an eclipse. I wonder what that gives you. Ooh, that's an interesting thing. Oh, what could you conclude from that? See, now the sun is also involved. There's a certain thing of the parallax there. Shadows in an eclipse. Oh, you sort of...
That's a guess.
That's a guess. Yeah, that might... I was wondering if it was a hint or a guess. Okay, it's a guess. Perhaps. Okay. There's this thing called triangulation, where if you were synchronized in timing, that you knew that you were 1,000 miles apart on the surface of the Earth and that the moon was at a different angle of parallax. Of course, you could triangulate it if you were very accurate. But then you also have to have very accurate timekeeping. I don't think the Greeks had that. I'm not sure how the Greeks technologically would have gotten the distance from the Earth to the moon, okay. But maybe they did. We'll have to think about that. Okay, now the point is, these 1 to 100 ratios, okay, all fine and good, but there's a certain calculation you need to do where you need the factor pi in there. I want to tell you how pi comes in. And it's like this. Let's go to the big board. And here is the Earth, and here is an observer on the Earth, and he sees the moon, and it occupies 1%. 1%, which we call 0.01 of the total arc of the sky. Now, what I want to suggest is that the length of the total arc, in terms of this figure of 1%, the length of the total arc, does everyone know how long the total arc is? It is 3.14, okay? 3.14. So the 1%, which is the moon, if you want to know in terms of, for example, that it's going to spend 12 hours, let's say it's orbiting about the equator, or that you're in whatever parallel latitude you were observing it at, that it was spending 12 hours making this motion. And you wanted to know how long, for example, that it was going to spend between the time that the disk touches down on the horizon and that it disappears below the horizon. Well, then you take this part out of 3.14, which is pi, so you take 1 part of 314 times 12 hours, okay, which is 12 hours, it's got to be 720 minutes, am I doing it right? Yeah, times 720 minutes, which is, you're looking at about 2 minutes, okay, 2 minutes for the disk of the moon, or equivalently, because we know that the moon and the sun are about the same radius disk, we know that because they occlude each other in eclipses, then we know it should take 2 minutes for the event of sunset to occur. Okay, and there is one other calculation you might want to do, which is to say, the question is, what percentage of the sky is occupied by the moon? Okay, this is another question. Okay, what percentage of the sky is occupied by the moon? You might want to ask that question. I'm not going to tell you why you'd want to be interested in that. You might want to ask that question. Okay, and then we gotta establish what is the surface area of the heavens in terms of these units, where the moon is 0.01, it's 1% of your subtended angle, whatever you want to call it. Now you got 3.14 as your length here. Now I've got to tell you something else. If this is 3.14 going around here, then the area of this circle is, what is it? We got 1 here, it's pi. The area is pi. Yeah, because if my semi-circumference is 3.14, my radius is 1, then my area is pi. You can see the area of this is about 1, and you got about 3/4 of that. So the area of the big square would be 4, so the area of the circle is pi. But if we then now say, okay, we're not talking about the area of the circle, but we're taking a whole inverted bowl which has that circumference, and we say, what is the surface area of the bowl when you overturn it and look up at it? Okay, we knew that the disk had an area of pi, and we say, what's the area of the bowl? Now everyone's got to know that the area of the bowl is exactly twice the area of the disk. I don't think I'm going to prove that to you, but I think you should know that. Does everyone know that? Did you know that, Sharon?
Can't say I did, Marty.
You might know it as 4 pi r squared, which is sort of how I know it.
There is a formula. There is a formula 4 pi r squared for the area of this, but the beauty.
We're not allowed to call those up on Mavs Marty, though.
Not allowed to use formulas on my TV show. You got to think in terms of interesting connections. Is that okay? Similar fact. Okay. You look at the moon, it's a sphere in the sky, it has a certain area that you see. Okay, the area that you see looks like a certain area, but the actual surface area of the full globe is 4 times the surface that you see, the disk that you see, and as compared to the surface of the whole globe, it's 4 times as much. Now, these are...
But it's not something you know without ever having sort of studied it, or...
No, how would you know it? I think the people are supposed to know this stuff. You see, this is my delusion.
Are you proving it with calculus? No.
No, I think it's a fact that whether
you're not born with it, so when do you know it?
I don't know. Why do I know it? I mean, I knew it as a fact before I could prove it. It's something, it's the kind of thing, look, that you got to ask this stuff. You got to be curious about it. It's knowledge that comes from the desire to make certain kinds of connections.
Well, that's great, but I'm saying, I'm just asking you if you knew it before any teacher in high school told you pi r squared, 4 pi r squared, you know.
To tell the truth,
2 pi r.
I don't remember when I made these connections. I don't remember, but the point is they're the kind of connections which I always have sought after. They're the kind of things which have made a unifying whole out of mathematics, because when you see something like that, that it's a numerical connection between the area of the disk and the area of the sphere. It's a factor of 4. And then you start wondering, Why should it be a factor of 4? Is there any other reason? It turns out there is wonderful reasons in physics why this factor 4 makes sense. I don't know if I want to get into that stuff here. Let us, however, remark that if by virtue of the calculation we've just done, that the sun itself, or the moon, occupies 1/628th part of the surface area of the heavens. Okay, 1/628th. It's about 1/6 of 1%. Don't really think I have any particular fact to relate that to, except, the sun is a burning fiery furnace, lighting up the firmaments above, I'm not sure if you can do this, but from that numerical ratio of 1 in 600 odd parts, 1 part in 600, if you can relate the temperature of the sun to the surface of the earth, this is the kind of physical thing that might make sense. I'm sure it's not true that the temperature of the sun is 628 times the temperature of the earth. That's the kind of thing, these are the kind of topics that go through my mind, and I figure I'm going to do a show on it. And by the time I actually got to sit down and calculate it out, it turned out to be nonsense. Okay, now I'm thinking on the air, so it's definitely nonsense. You can't be serious if there's 10 minutes left in the show. We haven't done a song yet. Okay, let's drop this stupid topic. Oh, that's not the organ I want. We're going to do this one with piano.